Tom Bizantz, also known as MisterNumbers on YouTube, has been called a math magician. He is the founder of Pattern Play Math, a unique, visual, fun, and whole-body way for preschoolers all the way up to 6th grade students to master basic math.
Today we're really playing with something new that you might have heard some of it, but it's so basic. It's an invisible problem. It's something that we normally don't see as a problem. And actually, my doctor told me about the problem and really helped me see it clearly. And I'll get into that in a minute. I'll get into a slideshow, which shows you a lot of stuff on it. And basically, it's about what an invisible problem for our kids the English language is. So I'm going to take you to my slideshow. And I am MisterNumbers, and what I do is pattern play math. And I call it for kids of all ages, because really kids are in a learning mode. And when we're teaching, we should be in a learning mode too. And this is a show for adults to learn, because kids learn this easier than adults do. So let yourself all be kids, and we'll learn this real easily. So what I'm doing is giving you tools to learn math, but also more importantly, to like math. Because it's when we get confused, it's harder to like something. If it isn't predictable, it isn't dependable. That's what we want our friends to be, is predictable and friendly and transparent, and let us know what's going on. And English words don't do that. So first of all, we need a good foundation for numbers. And this English language is a poor foundation for learning. And we teach by words and we learn by words. And the English language itself is actually pretty simple and pretty clear and very, very well developed. It's really good, but we confuse that with crazy names and words. So, yeah, we teach with words, and a poor foundation creates problems. And you can see that house, if there wasn't a good foundation there, all of a sudden the cracks start appearing. And that's what happens with kids with math. They don't have a good foundation with numbers. All of a sudden it's like things don't make sense to them. So how did I become aware of this invisible problem? My doctor showed me. What? Yeah, I went for my my VA, my veterans annual checkup. And my doctor, she said she knew that I was doing this math. I talked to her the year before, and she said, you know, what you have to do is read Outliers by Malcolm Gladwell. He has a whole chapter on the problems with the English language and math. And I went, huh? I don't know. What are the problems? And you might be asking the same question. What are the problems with the English language? Well, when you start looking at it, there are a lot of them. Okay? Now, we'll go back to Calvin and Hobbes, right? Because I love Calvin and Hobbes. My kids love Calvin and Hobbes. My grandkids love Calvin and Hobbes. Here's another math problem I can't figure out. What's 9 plus 4? Says Calvin. Oh, that's a tricky one. You have to use calculus and imaginary numbers for this. Imaginary numbers, you know, like 11-teen and 30-12 and all those. It's a little confusing at first. How did you learn all this? You've never been to school. Instinct. Tigers are born with it. Well, it is often confusing, inconsistent, and not helpful unless you're a tiger. Have you ever heard of 11-teen and 30-12 or had kids use words like that? It happens. Let's look at that Outliers book by Malcolm Gladwell, where he says, It turns out there's a big difference in how number naming systems in Western and Asian languages are constructed. In English, we say 14, 16, 17, 18, and 19, so one would think that we would also say 1-teen, 2-teen, 3-teen, but we don't. We make up a different form, 11, 12, 13, and 15. Now, there are 17 unhelpful words between 10 and 100. And what are those words? Well, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 40, 50, 60, 70, 80, 90. Are they all unnecessary? It could be. The Outliers book continues. The number system in English is highly irregular. Not so in China, Japan, and Korea. They have a logical counting system. 11 is 10-1, 12 is 10-2, 24 is 2-10-4, and so on. That difference means that Asian children learn to count much faster. A 4-year-old Chinese children can count on average up to 40. American children at that age can only count to 15. By the age of 5, American children are already a year behind their Asian counterparts in the most fundamental of math skills. Our number system is really good, but the names are terrible. Okay? Oh, the names are confusing. They are inconsistent. They are irregular. They're illogical. They're unpredictable. And they're not transparent. And they're basically not helpful for kids. Well, is there any alternative? What are we talking about? Well, take a look. This is my ruler, my tape measure, which is a good number line. And number lines are good in a lot of ways, but they're terrible in some other ways in terms of confusing kids. Okay, now here's our number line from 0 to 21, which are the basic numbers when you're learning addition and subtraction in basic beginning multiplication. Those are the numbers that you use, but the words are just terrible. Now, they're interesting, good structure, but look at those words. If you can read those, there's all those words, and most of them aren't necessary and are important. Many of our names for numbers are unpredictable and confusing to a kid. Now look at the structure here. We got 0 to 10, and then 10 to 20, and 20 to 30. So that makes sense, okay? That is easy to understand looking at numbers. But the words, once you get to 10, we're fine. But you get to 11 and you're on a number line and you've gone 1, 2, 3, 4, 5, 6, 7, 8, 10. Good, I got 10 fingers. It all makes sense. Now, what is this next number? 11. 11, it has 2 1s in it, but what does the word mean? Does it help me? There's no 10 or no 1 in the name. 11. What does the word mean? The word actually means I got to 10 and I had 1 left over. That's right. That's what the word means. Now, nobody knows what it means, but we use this word 11, which is not helpful and very confusing for kids. So what's our next word? Well, our next word is 12. Oh, now we got a whole new word with new beginning and new ending. It starts with TW, like 2, but it's pronounced different. And elf is new. It has a 1 and a 2 in it, but neither of those show up in the name. And it sounds different from 2. Huh. And it means I got the 10 and I got 2 left over. The English language goes back to like 450, a couple hundred years after Christ. And then 10 was an important number. And if you had 1 more than 10, then it was an important number. I have 10 and I have 1 left over. I have 12, I have 2 left over. And of course, 13 is I came to 3 and I have 3 left over. And it's kind of a crazy way to spell 3 and sounds different. And teen is a whole different word, sort of a little bit like 10 with an extra E in there. But it doesn't help kids. They don't relate to any of that. So let's continue on up this crazy number line here. And we get to 15. Well, it has a 1 and a 5 and it's fifth, but it's not 15. Huh. Okay, so you got to learn that word too. So you're learning all these new numbers so it's like this unending. And I've got this friend who he learned all these words and he got all the way to 19. And all of a sudden he realized that there were thousands, millions, billions of numbers. And all these numbers, did they all have a new name? Because every number has got a new name to it. And he just gave up and he quit for years. He's an engineer today, but he just totally went, this is baloney. So the names are confusing, and then we get more because when we get to 20, we end up with a new word spelled with TW like two, but it's pronounced differently. And then we go to 21. Okay, now 21 is, now we have the decade first. Like at 15, we had 5, it isn't even 5. So 14, we had 4, and then the decade. Now we've got 21, and we have the decade first, 20, and then 1, the unit second. So it's obscure, it's confusing, it's not helpful for kids to do it. And there's 17 new words between 10 and 100 that kids have to learn that may be unnecessary. And 11 to 19 are all unique words. And the decades are unique words. And 10 base is not obvious in the language, and the word meanings are not clear. What does 11, 12, 13 mean? You just have to learn it and know that they're associated with it. And the 10s and 1s sequence changes, 19 and 91. It just goes back and forth. And the average 4-year-old can only count to 15. Now, many students are bilingual, and so English is a second language, so that makes it even tougher for them. It can be easier. So let's look at a simple, useful, transparent way to look at numbers. No new words between 10 and 100 for all Asian languages. So if once they learn to 10, that's all they need to learn. They just rearrange the words so you understand it. So 11 to 19 are spoken as 10-1, 10-2, 10-3, etc. And decades are spoken as 2-10, because you got 2 10s. That makes sense. 3-10. You have 3 10s, 4 10s. So a 4-year-old counts to 40, and in English, they only count to 15. If you want to know more about that, read Outliers or the book Number Sense. They're really great at just showing you how language becomes a real big factor in working with numbers. Now, are we stuck with the confusing math language? Because we're in English and they're Japanese and Chinese and Korean and all those languages. Do our kids have to start a year behind and use a confusing language? No. Okay. One solution is a new language that you can learn in minutes. It uses the Asian approach as a guide, so it's really proven, because they tend to be a lot better in math than us, and a lot of it is because of language. And you just reuse 1 to 10 to create 1 to 100. So 11 to 19 are renamed, and it just becomes 10-1, 10-2, 10-3, 10-4, 10-5, 10-6, 10-7, 10-8, 10-9, and 2-10. Now, instead of just 2-10, we can just use T. So The decades then can be 10, 2T, 3T, and then guess what? We hit 4T. And I'll let that train pass. And then 4T, the number 4 and the T sound just like the word 40. So it ties back in with what I call traditional math language. And then there's 5T, which is similar to 50, and then 6T. Oh, now we're back again. Now we're tied back in, and it all makes sense. So 6T, 7T, 8T, 9T, and 100. And we've just counted to 100 with no more words than 1 to 10, 0 to 10. So what I do is I teach kids to be bilingual, meaning they are going to learn our traditional numbers for words for numbers, because page numbers and all kinds of numbers, the year, we use traditional names for those. But if they're using math, that's where what I call new number language, simple number language, SNL, is so much easier to use when you're doing math, because it actually, a lot of problems are solved themselves. So if you add 10 and 2, it's not 12. You don't have to memorize that and work that out. It's just 10, 2. That's all it is, just 10, 2. And 10, 4, 10 plus 4 is 10, 4. And 10 plus 6 is not 16, it's 10, 6. So it just simplifies a lot of math, doing it in many, many ways. And the language is easy to learn. I have kids go on a number wheel, like behind me, and they'll get around to 10, and I'll have them do the next number, and they do 10, 1. And I say, what do you think the next number is? And half of them guess 10, 2. And if they don't, by the time they hit what's the next number, they know it's 10, 3. They don't have to learn 11, 12, 13, 14, 15, 16, 17, 18, 19, and then go from language to numbers and numbers to language back and forth. So that's why it's just so useful for kids to do it. So yeah, it's simple and easy. Okay, so 11 is 10, 1, 10, 2, 10, 3, 10, 4, 10, 5, 10, 6, 10, 7, 10, 8, 10, 9, and then 210, or 2T is the way I go. And then 2T, 3T, 4T, 5T, 6T, 7T, 8T, 9T. And it sounds the same no matter which side of this you're on. And so that really is so much simpler to understand, and it makes sense, and it makes math easy too. Okay, so here is our traditional number language, and you can see all these words, and when you write them out, it makes it really confusing to kids. But with a simple number language, 10 is nice. It's familiar and it's comfortable, and kids know they have 10 fingers. So I think it's easier just to keep the 10. But then everything beyond that is, and notice that you don't have 30 down on the end, because 3T starts a new one, 4T starts a new one, and it's all 4. So it all lines up. And actually, if you check with Common Core, they really support switching at the 10s, not ending with the 10s. So here was one thing where like Asian students are just way above all the rest of us. And a lot of it is language. The other thing they use is an abacus for doing it. And what we use is actually the number wheel for doing it, and play. And there's an IQ difference? They say no, absolutely. It is not about that. It is about the language and their culture. I want to show you parts of my video on counting using simple number language. 8,
9, and 10. And we've gone all around the wheel, back to 0 in 10 hops, and counted all 10 fingers on both hands. Our friend Count Bunny jumped around to 1 on the tens wheel just now, on the left, to remind us we're now at 10. And we'll use 10 and the numbers 1 to 9 to go around the wheel again. Here we go. 10 and one more we simply call 10-1. This is helpful for many kids. It's also called 11 traditionally. And then we jump to 10-2, also called 12, but we won't use that traditional names right now. Jump again to 10-3, then hop to 10-4, and 10-5. We're at the bottom of the wheel. 10-6, 10-7, 10-8, 10-9, and 2 times around the wheel is 2 tens. And we'll just shorten it to 2T for tens. It's also called 20 traditionally. Aren't the simple numbers and names easy? They'll help us when we get to adding, and you will learn the other names later. We've gone around the wheel twice, so Count Bunny has hopped to 2 on the tens wheel. Let's keep going. 2T1, 2T2, 2T7, 3T8, 3T9, and as we reach 0, Count Bunny hops to 4, and that's 4 times around the wheel are 4 tens, which we'll call 4T. 40. Say, that sounds just like the traditional number 40. Yep, it's the same thing. Let's keep going. 4T1, 4T2, 5T8, 5T9, and 6 times around the wheel. Count Bunny jumps to 6 on the wheel, and we're now at 6T. We keep going. 6T1. See, that sounds like 60, doesn't it? 62, 68, 69. And as we reach 0, Count Bunny is now on 7 on the tens wheel. 7 tens are 7T, which sounds just like the traditional word 70. Cool, let's keep going. 71, 72, 73.
And we could continue to 8T, 9T, and 100 and beyond.
The kids really enjoy and get the simple number language. It makes a lot of sense to them. As adults and teachers, we need to be learning ourselves with it and know that kids learn it faster and easier than we do, and know that there's like a hump. It's like the whole metric system of learning it, and it's so much easier, than the regular measures of the English system. But we've got a lot of things that are complicated because when we have 2 measure systems, they measure different amounts base. But with numbers, we use the same 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It's the same structure. We're just calling it different. So it's much, much easier than that. In doing that transition is so much simpler, and going back and forth is so much easier to do it. That it's really a simple system to do it. And then you get to 2T, okay, for our next 0. And then 2T1, 2T2, 2T3, all the way through, and then you get to 3T. 3T1, 3T2, 3T3. It just makes so much sense. It's so much easier. So then you end up with 4T, 5T, 6T, 7T, 8T, 9T, and 100. I don't push at all. As a matter of fact, I don't push it. I actually recommend that kids choose going back and forth. And if they get stuck, then I push them to using the simple number language. And they find that it's easier. Okay, good. And then so some kids will use each of them, and then they learn both. And if you know anybody who's bilingual, you'll know that the transition for somebody who's bilingual is so easy to go back and forth between the two languages. And they can do that real simply, no matter, depending on who they're talking to or what they're doing, going back between the two systems of naming numbers. So I really feel like it could just tremendously help so many kids. It's one of the main gifts that I think I can give kids. And I'm really looking at preschool kids and kindergarten kids and first grade kids, of giving them that foundation that numbers can be easy, that they are easy. And we just throw these crazy obstacles. We tie a hand behind their back and then say, hold this ball, and they can't hold it with one hand. We make it a lot harder because of the language, and nobody did it consciously. It happened, 1,500 years ago that they created the language, and we think we're stuck with it, and we don't see it. Once you get past it, it all makes sense. But it's this huge obstacle for young kids to learn basic math, and we can stop that by just having them use simple number language, and then using the bilingual, understanding the other numbers and going, oh, okay, you call it that? That works for me. And that's how they can simply learn in such an easy way. And I see kids just really take to this method. So I hope this is helpful for you.
It's good, sir. The SNL is really good, and it's easy to teach kids.
Yeah.
The place value becomes easy for them.
Yeah. They take it because it's transparent and it's predictable, and they go, oh,
yes.
I can figure that out. And with the other number system, they can't figure it out.
Yes.
Figure it out. You just have to memorize all these crazy words. So this really is helpful. Yeah. Thank you for being here. I appreciate it.
Thank you. Yes. Thank you, sir. Thank you so much.
Thank you. Take care.
Thank you, sir.
All
Bye,
right.
sir. Bye. Take care.
All right.
Buddy, have you been over the hand, sir?